Alright, so now I need to talk about more exclusively about data types. So I'm just going to refer to this book that I was learning from before. I think I talked about it. It's C++ programming by Mike McGrath in Easy Steps. There's a chart in here that talks about data types. Let me just find it. There's basically shorthands that they give these things, and maybe it wasn't in this book. Okay, here's a shorthands. This is what it says in the book, and this isn't even all of them. But it says that we have a char or a char, an int, a float, a double, and a bool. So let's talk about those. So in C++, we'll call those up. So we have a boolean or a bool, and we can store a variable here. I'll call that variable 1. We also have one which is char. I'll call that variable 2. And we have a float. Var 2, var 3, and we have a double, and we have, of course, our integers, which I talked about in the last one, so I'm not going to bring that up. And then they didn't actually talk about that much, so I'm going to, off the top of my head, I'm going to bring this up as well. We have a string. This is another one I like. Let's call this, I guess, var 5, var 6. And there's also a W string as well, but let's not get too carried away. We'll just start with these basic ones. Okay. So a Boolean is basically, it just contains two states. It's either going to be a yes or a no. So technically it only needs to encode a single bit. The bit can either be 0 or 1. So you would think that it would just store like a bit, right? But it ends up storing whatever your system decides that it needs to store. But this gets into some more complex issues with hardware. But anyway, let's just make these initialize. All right, so let's initialize these. This has to be set as a character or something. We'll see if that can run it. We'll just pass this in here. Make that a string. Alright, so that executed. So this says the size is 1, so it uses 1 byte. Okay. Depending on the hardware, it might use additional bytes. Okay. So it uses a whole byte. So even though we wanted to code a bit, it doesn't encode a bit. It uses the full 8 bits. But the concept of a bool is that it only stores one of two states. That's either a 1 or a 0. So if I try to store the number 2, it should throw an error. We'll see. It might not. Okay, it didn't. But let's try to print var in here, and we'll see what that tells us. Okay. And we can see here it says the size of number. So I should say instead here the value is or something. Value is, and it says 1. Okay. So with a Boolean, its data type, it can use different amounts of memory, a byte or 4 bytes or something like that. But it's going to either encode 1 or 2 states, and that's either going to be a 0 or a 1. So even though I've stored a number 2 here, it's saying the variable for variable 1 is 1. So it can either be 0 or 1. So that's an interesting data type that you can use. When you want to store a bit value in memory, however, usually you want to exploit the full 8 bits of the bool. So usually you write a custom routine to actually do bit management. So we call that bitwise. I'm not going to talk about bitwise because that's going to be, I think, a little bit out of scope here. But dealing with bits is really powerful, we'll say. And you'll also encounter them in the wild too, because people will use them. Yeah, get out of here. Alright, so let's talk about the character. So we have a character here. Okay, and a character is basically how your Windows machine would store a character like your name, like the letter A or the letter B is a character. And how you would store a name is you would store a series of characters, right? So we would make typically an array, and we would store something like my name in there. Okay, let's see if that will compile. Okay, so that compiled. It says the var is Corey. Okay, so a character is a sequence of characters. So we have each one of the letters of my name is being stored as an array, and I just accidentally talked about arrays, which is going a little bit ahead of myself, so I don't want to go too far. But yeah, so you would store in a character just a single character. So I can store a letter C here. We can run this, and it just says C. And the amount of memory that this uses, so we use size of, is going to be proportional to what that would be for the text encoding for what the system is set for. So in this case, it should be set for ASCII or ANSI or whatever, and it should only use 1 byte. Okay, and so the letter C is stored in 1 byte. So that's what a character is, just 1 byte. Okay, so it's actually the same as if you said int 8. Okay, like this, it would store the exact same thing. It's just 8-bit integer. So when you're talking about integers, you might want to be dealing with, because when we talked about int, I think I explained that the int type stores 4 bytes, so it's actually a 32-bit integer. But what if you wanted to store half of that, right? You would have to use a different data type. So when we're talking about basic data types, these are usually the basic ones that you get, which is 1 byte, 4 bytes for integer, basically. Okay. And the special thing about the char type is that you can store a sequence of them in an array, which I showed you, but I didn't really want to get into the topic, but I guess we'll go over it. Basically, an array is just basically a sequence of numbers. And you don't have to do it with just char. You can do it with any one of them. You can store a sequence of stuff, which is fabulous. But primarily, when you're talking about older machines, they would store your text as a char. As things are right now, you wouldn't do it that way anymore. Okay, but that's just the way it was named before this. All right, so we'll just get rid of that. All right. So yeah, we're done with the integer. So let's talk a little bit about the float. So float is a very interesting number. Maybe I don't know if I should bring in the wiki. The wiki might be a little bit confusing, but I'll just try to explain it. Okay, so let's say we have like a number, and I'll just type in some random numbers. Oops, it's created some really bad stuff, and I think it crashed. Okay, here we go. Just type in some random numbers in here, and let's just convert it into binary. So I have a binary representation of that. I'll just paste it in here just to show it. So let's say we have binary representation. Now, most of our data types are just whole numbers. So the float will allow you to store a fractional number like 1.5 or something. So to do this, they wanted to keep the same even amount of bytes. So for example, a float will consume 4 bytes of data. And just to show this in a hex editor here, we can type in, trying to remember, is it 3F8000? Is that what that is on here? No, I got it backwards. Alright, so this is encoded, and that's just a 4 byte, okay? Or not 4 byte, but 32 bits, okay? And they're encoded, but it's encoded to a single, or what they call a float 32. So it's a float point using 32 bits of bits, right? And this says it's 1. So if I click on this, this space gets highlighted, and it's the number 1, right? I think if I make this like a 4, it becomes like a 2 or something, or like a 0.75. There you go. So you can see that it does store fractional numbers, right? So it does, where if we use integer 32, it can only do a whole number. Float point will allow you to do fractions, which is powerful because you would need to store fractions when you're dealing with anything that you're dealing with on your computer. You need to store a fractional number that has a decimal point. So float point basically defines the number into parts. So you can store a number, and then the float point means that the decimal point can move around anywhere. And that's it's standard in the encoding. So they basically reserve amount of bits for the whole number and the fraction and the signage and all that stuff. And when you combine it, it makes a number that makes nonsense. So if we look at here, and I click here, the float point representation is 0.75. And that makes sense. But then when we go and look at the actual 32-bit integer representation, we get some astronomical number as an integer, something like 1 trillion something something something. So when we're identifying numbers in hex editor, some of the numbers don't make sense. So that's why we need the data inspector, because I can click here and now I can see, oh, well, this doesn't make any sense. But oh, that makes sense. That must be what this is. It's a float 32 or a single. Okay. And now a double is just basically the same thing. It's just twice the size. It's 64 bits. It's a float point still. Um, and the difference is they call this double because it's double precision. When we're adding more bits, we're talking about the precision. The precision means how many decimal places you can go before you can't go anymore. So yeah, so single pretty much is good for everything else. Typically in your everyday life, you want to store numbers like 0.75 or something like that. When you need to use a double, this is like when you need to pilot a spaceship or something where a fraction could cause something to explode or something. So the doubles are basically reserved for high precision, what they call high precision. So we have obviously 32 and 64 bits. There's also different standards as well for an 8-bit and a 16-bit. We do encounter those in the wild, but I'm not going to cover it right now because they don't have a standard encoding, and so their encoding is sometimes a little bit left up to interpretation. Anyways, so that was the float and double. So now if we just check the size of the float, you'll see if I run this, it should say 4 bytes, and the double should say 8 bytes, okay, as we had witnessed in the hex editor. Okay, so in here it uses shorthand names like float and double, so you don't understand on this side how many bits it uses, so you don't know, right? So when you're calling up a variable like int, whatever, or whatever your char or whatever, as a programmer, you don't care. It doesn't put it up in your face. Like, you don't think this is a float, this is a double, this is whatever. So, when you save it to a file and then you're somebody who's trying to inspect the file and pull data out of it, okay, that's when you need to care and think about, oh, what is this? This is a single. Oh, is this an integer? Because then you have to go back into here and reverse it. You have to write a program in reverse, specifying each one of the data types properly so you can read the file back into a program. So that's why we call it reverse engineering. Okay, oh yeah, I'll show you the last one, which is the string type, which we just have there, this. Now it might show a dynamic size. Let's see if that does or not. So yeah, so you can see here, we just stored this, which is 0. It just uses 1 character. So you would assume that it uses 1 byte, like the character type did. But you can see here the string is reserving 24 bytes of memory. The string type is a very interesting type. It's a dynamic sized variable. So that means that at any point you might add stuff to it, like, I don't know, something else to it. So it reserves more memory than it needs so that you can append stuff to it. So you do see this also in memory. You see fixed length strings and also dynamic sized strings. And we'll kind of cover those as we go through, I guess. Okay, hopefully this talked a little bit more about the advanced types. And then later we'll use this in practice, I guess. We'll starting to get our hands dirty. All right, see you in the next one.